All right, guys, so we are looking at example 11 from section 2.3. This is from our college algebra course. And number 11 and 12 are actually pretty similar to each other. They're basically asking us to identify what the equation will be based on the polynomial, right? So let's enlarge this graph a little bit so we can see some of those details. So basically, you can see how this graph has, two hills and one valley, right? So basically, it has a total of 3 hills and valleys. So that actually tells us the degree of our polynomial is going to be 1 more than the number of hills and valleys you have. So that actually tells us the degree of our polynomial is going to be 4, because remember, the number of hills and valleys is usually n minus 1 if the degree of your polynomial is n, right? So if this is a degree 4, then 4 minus 1 will basically end up giving us 3, and you end up with 3 hills and valleys. So we know that we are going to have a degree 4 polynomial. Okay, so that's the first part. Then the next one, and I'm going to erase this, should be to look at the x-intercepts. So you will notice that the x-intercepts are at -4, -1, +2, and +4. So again, our x-intercepts are at x equals -4, x equals -1, x equals +2, and x equals 4. Once you have that identified, then you should see, is your graph crossing the x-axis at these x-intercepts, or does it touch but does not cross the x-axis? Of course, you can see our graph is crossing because you're going on either side of the x-axis, right? So it's crossing at -4. Our graph is also crossing at -1. The graph is crossing at +2, and the graph is crossing at +4. So if the graph crosses your x-intercept, crosses the x-axis at those x-intercepts, that tells you that each of the factors that is associated with these x-intercepts is going to be an odd exponent. So basically, if the graph is crossing, then the exponent or the multiplicity, you can also think of it in terms of multiplicity, the multiplicity will be an odd number. If the graph were, instead of crossing, let's say if the graph would touch but not cross, so, it might end up looking something like, and I'm just going to use a separate point. So, if it was doing something like this, what we see like on a parabola. So, if instead of crossing, it would just touch the x-axis at that point, but it would not actually physically cross the x-axis. In that case, we would say the factors associated with those intercepts would be raised to the even power, not necessarily second, to the even power, or we would basically say it has a even multiplicity. But that's not the case in this example, since it's crossing at all 4 x-intercepts. So basically, since we know this is a 4th degree polynomial and we have 4 intercepts, the general format for the equation for this function would basically be, you would have a leading coefficient in the front of your polynomial. Now, it could end up becoming 1, -1, something like that, but we're just going to, at this time, call it A because we don't know what that value is going to be. And then since we know this is a 4th degree polynomial, we should have 4 factors, right? And I'm just using generic M and P and Q as our variables, but basically, since we know what all 4 of those x-intercepts are, that actually tells us, since we should have 4 factors and we have 4 separate x-intercepts, we can actually come up with what each of these factors are going to be. So you have x minus, and we can say, M could be that -4. So you can basically see you end up with x minus -4. So 2 negatives end up becoming positive. So that first factor will end up becoming x plus 4, which will actually represent that x-intercept. For the second one, we can do x minus, and then our next x-intercept was -1, so we can do x minus -1, and same thing, right? Negative times negative becomes positive, so this guy will end up becoming x plus 1, which will, of course, represent the second x-intercept from the left. Then we have x equals 2, so this guy can be x minus 2, and this one, of course, will just end up staying as x minus 2, which would, of course, represent the third x-intercept from the left. And then the last one would be x minus 4. And, obviously that would also end up staying as it is, and you would end up with x minus 4. I'm sorry, and I'm kind of writing on top of each other. So you can see we are able to come up with our 4 factors, right, which represent each of the x-intercepts. Now comes the question of what should our leading coefficient be, and this is where you would actually need to use your y-intercept. So again, let me just make that graph a little bit bigger. So you can see our y-intercept where the graph is crossing the y-axis at happens to be at this point, which is, of course, the point 0 for the x value, -1 for the y value, right? So your y-intercept is going to be at 0, -1. And so using that, let's go ahead and put that in here. So our y-intercept is going to be the ordered pair 0, -1, and we will need to use that to actually help us figure out what that leading coefficient of this function is going to be. So our y value is -1, and we are going to need to use that to figure out what our leading coefficient is going to be. So actually, let me not put that there. And I'm just going to replace that f of x with the y, so you can just kind of see where the substitution happens, right? Okay, so to find a, there's a couple things you want to keep in mind here. You will see that your function is opening downwards, right? The arms of your function is heading downwards. So this actually tells you your leading coefficient is going to be negative. So you are going to have a negative sign in front of your function. So there will actually end up being a negative in front of that a value. So we should have negative. So keep that in mind. That's not going to affect the answer for a, but obviously we need to consider that when we start calculating for the a value. So this is where the substitution will happen. Our y value using the y-intercept, our y value is -1. So replace that f of x or y with -1. We're trying to find the a. In the y-intercept, remember your x coordinate is 0. So everywhere we have x in our generic form of the equation, you're going to replace it with 0. So you will end up with 0 plus 4 for that first ordered pair, 0 plus 1 for the second one, not ordered pair, factor. 0 plus 4, 0 plus 1, 0 minus 2, 0 minus 4, right? So again, -1 for the y value, -8, 0 plus 4 is 4, 0 plus 1 is 1, 0 minus 2 is -2, 0 minus 4 is -4. So, go ahead and multiply those numbers on the right-hand side. And we will end up getting 4 times 1 is 4. 4 times -2 is -8. -8 times -4. So 2 negatives will become positive. -8 times, 4 times 2 is 8. So 8 times 4 will, of course, end up becoming 32, right? So you end up with 32 when you multiply all 4 of those numbers on the right-hand side, which is obviously still being multiplied with -a, right? So go ahead, divide both sides by 32 since we are interested in finding just the value of a by itself. And you will see we end up getting -1 over 32 is equal to -a. Since we have negative on both sides, you can either multiply or divide by -1, which will actually end up giving us the a value as +1 over 32, right? So that's what your a comes out to be. And then in our equation, and I guess I'm going to put this here up top, your f of x, which looks like they're actually calling it y of x. So if you want to use that notation, we can say this guy's y of x is going to end up becoming, remember we have the negative sign because our equation or our function opens downward. So the negative, our a value came out to be 1/32. And then of course, each of our four factors representing the x-intercepts were x plus 4, x plus 1, x minus 2, and x minus 4. And since I'm in teacher mode, I can actually show you the solution here. And I might have to navigate that a little bit, but you can see we have the negative 1/32 in the beginning. And then you have x plus 4, x plus 1, x minus 4, and x minus 2. So that is how you would come up with your equation when you are given the graph of this function. So take a look at this. Let me know if you have any questions and if you need any further explanation. All right, everyone, good luck. Take care.